In this section, we're going to perform an operation that many systems administrators end up having to perform because of consolidation needs of logs. We're going to attempt to write a bash shell script which will parse all of our logs on the system as stored in /var/log or any other directory on the system that we specify in the script. And the script will get the matching log entries, at least for a given date, store them in an alternate file so that we can process these entries from multiple sources or consolidate those and the entries from multiple sources into one particular file. So in other words, we're going to create a log abstraction script. It's quite simple. The logic is relatively easy, and as we've done thus far, pretty simple scripting. Let's open a shell, and we'll talk about some of the things that are required to get this working. Let's first examine where logs are typically stored within a Linux system. And you should be fully aware by now, let's just fully justify our screen, that the logs are stored within var log. Here you'll find all of our logs, and we can process them however we want. Now in our script we'll put an entry for the logs that we're interested in. The logs with suffixes, numeric suffixes, are or have been archived. So we're going to be focusing on logs that don't have numeric suffixes. So for example, the mail log contains numeric suffixes up to 4 because the log rotation scheme within a Linux environment typically rotates logs and keeps them for at least 4 weeks, or at least for 4 rotations, usually based on a weekly cycle. Great, so we have some logs that we want to process. Let's go to our directory where we actually work on this stuff, and we'll be in temp2, and we have our scripts here, and we're going to create a new script that will be called log abstract.shell. So let's nano log abstract.shell, and this is where we'll perform our work. We'll set up our typical headers, and we'll specify other information, including date and purpose. The purpose is to illustrate how to abstract daily log entries. So somewhere in this body we need to come up with the logic. Now before we go off writing any code, let's take a look at one of the files. Let's Control-Shift-T and we'll go to var log. Let's take the messages log file for example. The messages log file contains system messages, general system messages. And usually the syslog is configured on a Linux system so that all messages that are not routed specifically to its own log file end up in the messages file. So this is a general purpose log file, the messages file. Let's head perhaps the first 2 lines from messages just to get a feel for what we're dealing with. Now, it just so happens that today is Sunday and the messages file was rotated today, so we're only going to find entries in this file that pertain to today. But to illustrate our point, we can operate on messages.1, which contains a full week. So does 2, so does 3, and so does 4. So the other files, messages.1 through .4, contain various entries that span at least a week, whereas the messages file contains entries just for today because rotation occurred perhaps slightly after midnight or whenever the log rotation runs. It could even be after 4 a.m., depending on the cron entry, of course. And the cron daily items get rotated based on the entries within cron daily. And you'll see log rotate is in here. And cron daily runs, we can cat etc cron tab to see when the cron daily entries actually run. And on a Red Hat system, a default Red Hat system, it should run, as you see here, cron daily 4:02, 2 minutes after 4 a.m. every day. So again, our entries contain log entries for October 17th after 4:02 a.m. So let's look at our log again. We'll run that head script, and here's what we're going to be looking at. We need to come up with some sort of logic, one, that will allow us to process multiple log files, and 2, to be able to go through the entries line by line and find matching lines or lines that match our current date. So, sounds a little tricky, but there is a one-liner and there is a utility that we can use, the grep utility, to help us achieve our objectives. Now, we don't cover grep fully in the Bash edition. In fact, we do have plans to release a grep awk set edition for the sole purpose of processing fields, lines, etc. as a separate discipline. But nonetheless, you should have some basic idea as to how grep works. Grep parses lines, and wherever it matches what you're searching for, it returns the line. So in other words, if we say grep Linux CBT serve, it'll return every line. Of course, unless our system serves as a syslog server for other servers on the network. But perhaps we could grep for zone, and only lines containing the word zone would actually be returned. So grep in its default state will return a line which matches the characters that we're searching for, or the words that we're searching for. So we're going to have to construct some logic around the grep command to enable us to achieve our objectives. But that's not all we'll need. We'll also need to loop through the log files. We'll also need to perform comparisons based on the date. Now, we expect to run this script as a daily abstract. It could be changed for a date range, but we're going to set it up, or at least get you off and running for a date that's based on the current date, today. So let's go back to our script. That should tell us we need to set up some variables. First, we should define variables that pertain to the log files that we're interested in parsing. So what we can do is begin by parsing one log file, and we'll call that variable log1, and you'll see why we're calling it log1 soon enough. Log1 will be equivalent to /var log messages. This is the file we want to work with initially. So we have log1. Now, we also need some sort of date representation so that we can actually instruct our grep utility to perform the comparisons on. So in other words, we need a way to come up with a date that matches what's within these log files. Well, by looking at the log file, the messages file, just the first two lines, we can tell that in order for us to perform a match, we're going to have to match the abbreviated month, which in this case is oct for October. And we know there's a variable that date provides that allows us to extract or represent the date in such a format. It's in fact the %b, lowercase b variable. And we also need the date represented, as you see here, 17, which we can get using %d. We're not interested in the time, we're just interested in the date because we want an abstract for the date. So if we do date help, you'll see the various variables that we can use to extract the date in a form that actually matches what's within the system log files. So if we take %b, we'll get an abbreviated month. And if we also take %d, we'll get the time, the date stamp that we want, the actual date, not the time. %d will return the date as you see it, the day of the month as you see it there. So let's try that. We'll do date plus %b, and we want a space. We'll also do %d, and we'll see how it comes back. This matches exactly what's within our messages file, oct17. So right here, you know, we need to set up some sort of variable which stores the date in a similar fashion. So let's copy date plus %b with a space escaped %d and store that in a variable. We'll call this variable myDate. So myDate will be equivalent to command substituted execution of the date command, which will return oct space 17. So we have the date variable, but we need to do more. We have a log file. We need to set up a looping mechanism. Well, in order to set up that looping mechanism, we just define a for loop. A for loop is the easiest way to go about it. You can just set a variable for log, for example, in, and we can just say for log in log, and then we can use brace expansion to actually specify the values that we're interested in this case log1, but then as we grow or include additional log files, we'll just separate them using the comma separator. So for log in log, we're going to do, and then when we're finished, we'll have done. So somewhere in the body we need to come up with the logic necessary to get us going. Before putting in any of the grep logic, let's actually echo what the log variable has in store. So in other words, the log variable should come back with the current value of log 1. This is an easy way for us to pass the contents of log 1 into our for loop. So the reason why we named our variable log with an extension of an integer is so that we could loop through it in an easy fashion, rather than actually separating the values, the string values. We could have called, for example, the log variables, or the variables that store the log file directory path and name, individual names such as messages, secure, etc., and have for loops through it. It's just that it makes the script longer. So first and foremost, let's echo. We'll just separate ourselves with a tab here. Well, let's echo what the current value of the log variable is. That's the first thing we should do, just to be sure. We're essentially debugging as we go. Now we can specify the additional integer for the second log file that we've yet to add, and it'll just serve as a placeholder, and it instructs bash to loop through. And it'll set the first value for log to log 1, the second to log 2, which doesn't exist currently, so nothing will be echoed. We won't return an error. Let's open a shell, another shell. We'll navigate to temp2, and we'll execute log abstract.shell, and it returns var log messages. So we know thus far that we've captured the variable, the value of the variable log1 into our loop. So at least we know we can operate on it. So we've proven that now we can cycle through multiple log files. So let's append another log file. We'll just Control-K, Control-UU to paste this twice. We'll change the second variable to log2, and we can also navigate through a different log file. Let's go through the mail log, for example. And now when we return to our third window, it'll echo both. So we have var log messages, var log mail log. So we have two that we can operate on currently. Excellent. So we're setting ourselves up nicely to actually perform the grepping necessary. We have my date, which we're going to instruct grep to operate on, and that'll help us out. We'll also set up a myScript variable, which will store the name of our variable so that we can write an error file using standard error in the event that we have problems, of course. So what we'll do next is continue the logic. We'll explain what we're going to be doing with grep. We'll show you how it works, and then we'll finish off the script. So let's continue what we're doing here. Now before getting into the for loop, let's just echo my date to ensure that the values are right. Again, what we're doing is none other than debugging as we go along so that we make fewer mistakes. We run it, we get oct17, we also get the two log files that we're interested in. Great. This can be commented out, we don't need it, or you can just get rid of it. So we have our loop. How are we going to actually process the log files using grep? Well, let's go back to the second window, which contains a location, or has us currently in the log directory. So there are a bunch of files. We have messages, etc. And we can cat messages. You'll see all of them are prefixed with today's date, with short month and the day of the month. How do we get the values out? Well, grep will actually parse lines, but we can teach grep, and of course it accepts many options. We can teach grep, or tell grep, to pull the lines that we're interested in. Now you may be wondering, how are we going to pull the lines that just say October 17th? Well, grep supports regular expressions, and it supports a few types of regular expressions, including basic, extended, as well as Perl regular expressions. This is a pretty simple regular expression that we need to define. So we need to tell grep to search for a pattern based on a regular expression, and when it finds lines that match the regular expression, extract those lines. It's really that simple. Let's scroll down and show you that the option within grep help, which will actually enable it. We can use a -E, and this will allow us to have grep perform extended regular expressions pattern matching on the files that we process. Now the regular expression is quite simple, and we'll show you how to define it. First and foremost, before we do it, let's actually run the command from the shell. Since bash scripting is none other than gluing together multiple commands run from the shell, let's just run grep with the necessary options and patterns to make this work. So you tell grep, and you'd have it run with either single or double quotes, and you would want it to export the values from, or the lines from the file that match the actual date stamp variable that we're using, or at least our representation of the date stamp. So if we were to do, for example, date plus %f, and in fact we can just get this with command substitution, but in the script we're going to use the quotes with the variable. So we want %f, or in this case not %f, we actually want %b. We want to escape a space, then %d, and that'll give us oct17. So we're going to grep this particular pattern from, let's say, messages, and it'll go and it'll search it. But messages contains entries just for today, so it matches regardless of what we try. Now let's enclose these results, since we're using date. When we pass it into grep, and we've enclosed it in single quotes, and you notice no values were returned. The messages.1 file, however, contains values that match other days that we could extract. So for example, we could say oct and perhaps the 15th, and here we've extracted results from the 15th and only the 15th. We could even pipe these to the word count and get the number of lines, 272 lines. So again, look at the syntax. We specify the uppercase E option, and within single quotes, at least from the command line, we can specify our regular expression. Regular expressions match patterns. We know the pattern that we're searching for. We're searching for a date which matches today because we want an extraction for today. So oct15 gets oct15 from messages 1. Messages 1 certainly contains logs for other dates. We could get the 16th, for example, and we'll take it off from the count and go through the 16th to see what entries are there. There are entries for the 16th, only the 16th, and no other dates. We could even search for entries for the 17th, which is actually today, and we should find some entries up until 402. That's when the log rotation script on our system runs and rotates the logs. So I think you get the picture. We need to use grep with regular expressions to extract lines which contain a matching date of today, October 17th. So back to our script. We can actually cut this or copy this and paste it into our script, into the body of the script, but of course we're going to variabilize it. So we want the -e option. We're going to include within double quotes because we're now inside of the script. But we're not going to specify oct17 because when tomorrow changes to the 18th, this script will need to be updated. So we should variabilize it, and that's why we specify the myDate variable. So now we just say myDate, and there you have it. Now we've put in the date variable and we've passed it into grep. And again, we don't want grep to actually search or parse just messages.1. We want it to parse the current value of log, which is why we echoed it to show you that it's actually working. So grep is now set up to parse the log file, the current log file, as bash iterates through the values of the log files. Great. Now we can do a little bit more fancying up here. We can echo begin so that in our outputted file, because when this is all said and done, we're going to send the output to a new log file so that we can take a look at it. So let's echo log begin, and at the end we'll echo log end, so that when we're reading the result file, we see where it begins and ends. And let's even echo an additional space after, so that there is some space between the different or the various log files. Excellent. So far we have some logic going on here. We're ready to grep, but we're not yet ready to send this output to a new file. We need to do some more. Now what we want to show you is what would happen if, for example, grep were to fail. First, before we dump this to a file, let's show you it succeeding. Then we'll actually show you when it fails, so that we can handle those problems. So let's run logabstract.shell, and logabstract.shell goes through and it looks for values. Now it's gone through first the messages file. Let's go up. We should see if it hasn't exceeded our screen. Varlog messages begin, and these are the entries in varlog messages. Varlog messages contain values for the 17th. It ends it, and then it begins the mail log, and then it ended the mail log. That's cat varlog mail log. You'll see it's empty. In fact, it may even be 0 bytes. Let's lsl varlog mail log, and it is 0 bytes. And we're going to show you how to handle that in a second so that we don't end up with superfluous information in our result set, in the result file. Great, so we've extracted. Our script is working so far. It's gotten just entries from the 17th from the messages file. We could even do the same for messages.1 as we've shown you. Just update the variable and cycle through the results again, and we'll see the difference this time. There you have it. It's extracted all of the results which match the 17th from the log file, which was rotated this morning at 4:02. So it contains only X number of entries versus the current file, the live file. So our logic is working. The heart of this particular script is this one-liner, this one-line grep command. And again, down the line, if you're interested in learning more about grep, awk, sed, and even expect, which allows us to alter non-interactive applications and interactive applications, be on the lookout for a different edition which will cover those languages in general, which target lines, fields, etc. Great, so back to our script. So our regular expression is working. It's all basic, but we've gotten the variables we want. We can cycle through the files that we're interested in. What else do we want to do? What if we had errors with this script? What if grep, in attempts to parse the information from a file, returns an error? Well, we should handle that error using standard error. So we can send the output from grep to standard error. Before we do it within the script, let's show you how we do it outside of the script. Let's say, for example, we want to run the script, log abstract.shell, and send it to standard error. Just send the output, the standard error output, using > sign, to some file. We'll call that file log abstract.errors. And this will store any errors if returned from the file. Now let's lsltr. You'll see that the file was created, but there were no errors to report, so it's empty. We're also going to show you how to handle that exception as well. That's cat log abstract.errors, and you'll see that it contains nothing. In fact, we misspelled it. That's log abstract.errors. There's nothing there, so let's remove it. There's no need to have it around. Excellent. So there are no errors, and it returned properly. How about if we force a condition where there's an error? Let's define one of our log files as a bogus file. So let's call it mail log bad, which we know does not exist. Let's go back and try to run it, and we'll send all errors to this log file. And let's just fix the name. We'll make it log abstract.errors. Now our file should contain errors. Let's take a look at our directory. We'll lsltr, and log abstract.errors now contains errors. So we've sent the standard error as reported by grep to a file called log abstract.errors, which we can now cat, and it'll show whatever the error as grep sees it. No such file or directory. Excellent. So we have a way of capturing our errors from outside of the script. Let's show you how this would work from inside the script. Let's remove rf log abstract.errors. It's gone. We can lsltr. That file's gone. Back to our script. On the same line where you run grep, just do the same thing. Send the output, which is the file descriptor number 2, standard error. Again, there are 3 file descriptors, 0, 1, and 2. 0 is standard in, 1 is standard out, and 2 is standard error. So we'll send 2 to a file name. Now that file name can be a hardwired name, such as the following, log abstract.errors, and it's never good to hardwire anything. It should be all variabilized. Let's try to run it. We'll see what happens. We'll get rid of this, and the script will just run in its normal state, and it will produce the error file for good or for bad, whether or not it contains entries. And it does contain entries. Let's cat its contents, and it has the same error. Let's remove it again and show you how to variabilize this. So now we want to variabilize this file. Instead of actually sending standard error to a hardwired name, we should have a variable which stores the name. Now, ideally, you can make use of the variables that Bash stores internally to send output of a script to a same named file, at least the prefix, with perhaps a suffix of errors. Let's show you what we mean. You can define another variable, call it myScript, or whatever you want to call it, but myScript is easy enough. And myScript will be equivalent to the base name of the 0 variable which stores the name of the script. So now we can send errors into myScript, and perhaps we can even append a suffix, such as .errors, or we can append the suffix in the variable. So it's going to be equivalent to the name of my script .errors. And now we just send output to my script. And then that's it. Or maybe you want to save my script for use in some other fashion, and then create a separate variable which is like my script with a suffix of errors. So perhaps you do something like the following: my script errors is equal to my script dot errors. And now we can just send our values, or at least our error values, into my script errors. Let's take a look at this. And we'll rerun the script, log abstract. Now let's take a look at the directory. We now have a file called bash.errors. If you're wondering why is there such a file, quite simple. When you source a file the way we've done so far, using dot, then the script name becomes bash. In other words, the script is actually not executable, and because it's not executable, it assumes the name of the interpreter, which leads us to the next part. We need to flag our log extraction script file as executable and run it as its name, so that the script name, which is interpolated using base name, and stripped using base name and interpreted within the script file, actually gets exported or exposed as its proper name. So let's cat bash.errors, we did, and let's remove rf bash.errors. And now let's flag using changemod u+x log abstract.errors.shell. And now when we run log abstract.shell, it will produce the right errors file. Let's lsltr, and now we have log abstract.shell.errors, which we can of course cat, and it'll contain the same problems that the file doesn't exist. Now these aren't the only errors you'll find here. Any problems that grep has had thus far, it'll send to file descriptor number 2, which is standard error, and we can capture it in a separate file so that you can analyze that file. So we have quite a few variables here. We have my script, which is stripped using base name. We have an errors variable, so we can send our errors to. We still need to do some more intelligent processing based on all of what you've learned thus far, so that we come up with a pretty neat script. So next we finish off the script putting in some more logic. Alright, so we've made it to part 3 of this log abstraction script, and we've tried to explain all the logic necessary so that you can use it not only for log abstraction but for other scripts. So we're dumping our standard error, which is file descriptor 2, to a separate file. We have our regular expressions properly defined using grep. We're echoing a begin line, which has the log file name, and an end line, so we can delineate within the exported file, which could potentially be a pretty big file depending on how large your source log files are. So what else is necessary to clean up this particular script so that it runs better? There are quite a few other things that we can do to make this nicer. So first we're going to need some additional log files, or eventually we'll need some additional log files, and we'll add that. But for now, let's just get rid of this bad file so we don't end up with any file descriptor problems or any errors because the file descriptor number 2 has been redirected, standard error. So there's some other things we want to do. Well, we can avoid, if you think about it, some of the errors that we may run into within the heart of this particular for loop by checking whether or not the script actually, or the log file actually exists on the file system before passing it off to grep. That's what bash shell scripting provides. It provides conditional testing or tests which allow us to check whether or not the file actually exists. So what we should do is nest that within our particular for loop so that we don't end up with superfluous output as you've seen before. Like here, for example, at the end, we're printing, for example, var log mailbad begin and end. This would all end up in our result file. We shouldn't have it there if the file actually doesn't exist. So let's build some logic for that. First, we'll simply say if, and this is all nested, and we'll use E, the tester, which tests whether or not the file exists. And we get the current value of log. So if the file exists, then we process it. Otherwise, we don't. It's that simple. And we'll end it here. Let's just indent so it's easier to read. Excellent. So if the file exists, then process it. If it doesn't, it won't process it. Let's take a look at the difference. We'll clear screen here, and we'll rerun our log abstract. And as you can see here, it's run. Now let's take a look at our error files just to see if there are any problems. Log abstract.shell.errors has no values in it. It's 0. Great. So just that simple test alone avoids any problems. Now let's create a condition where it should fail, and it should properly skip this the processing of the log file. Let's make mail log again, mail log bad, a file which certainly doesn't exist. Let's rerun the script. As you can see, big difference. It processed the messages file, and it also added an end for messages as it's done before, but the script has terminated after it. In other words, it has ceased to process a non-existing file. Let's lsltr. Log abstract.shell contains no errors this time. In other words, we didn't pass any junk into grep, but it's still good defense to send a standard error from grep, because grep may run into other problems. Let's say, for example, it has problems finding matching lines or some other problem, locking with the file. Anything else could come up that could cause grep to send its output to file descriptor number 2, standard error. So this is still good to retain within all of your scripts. So great. In this case, we didn't process mail log bad because it doesn't exist. There's another condition that we need to look at. Let's go to var log, and we've purposely created, let's LSL here, auth. There's a file called auth. The auth file is a blank file. Whenever log rotation occurs, a new file gets created, but it doesn't mean that the file will be populated. For example, auth is a blank file. Let's LSL mail.log or mail log. Mail log is a blank file. We shouldn't process files that are blank. In other words, we're going to populate our result set with superfluous information if we attempt to process a blank file. Let's show you what we mean. We'll rerun the script. In this case, you see it's printed an opening line and an ending line with no data in between, no log output in between. That's not good, because then our resulting file will end up with garbage in, garbage out. So let's fix that. There's another test that we can perform. We'll say if the file exists and using -s and the file is not a blank file, so and the file is not blank, then we will process. So let's take a look here. So we have two conditions that we're studying here. One is whether or not it is actually a file, and two, if it's a blank file. Now let's rerun this and show you what would happen. Now let's lsltr. The file does exist. No errors in our file here, and notice the error that, or notice the output that's dumped to the screen. This time it doesn't process mail log. Let's go up. You'll see before it did process mail log, because towards the end it outputted information for mail log. And we'll go up with, we did it 2 tries ago. So before it actually processed mail log, now it's not, because we're saying we don't want to process files that are blank. Good. So we've made some good changes. So we're doing 2 tests, one if it exists and one if it's 0, or if it's not 0 byte length, then great. We should be able to not process that particular log file. Excellent. So we have 2 tests going on, and certainly there's more we can do. We're almost complete with this particular file. We can process as many as we want. We should be sending the output of this file, of course, to a result file. So we're going to run this script and redirect its output to the result file, and that's quite easy, of course, to accomplish. In addition, we can clean up any error files at the end. So for example, after the for loop is complete, we should just have a separate conditional which says if the MyScript errors file, for example, so if this file does exist, the MyScript errors file, if it does exist, and based on the logic we just mentioned to you, and this file, we want to put a negator here for the S test. Let's just put MyScript errors, and here we misspelled it. As a result, what we want to do is to remove the file. And we'll show you how the logic works. And this is MyScript errors. And then we'll close the conditional. So what we're going to do is, if the file does exist, because we've created it, if we've created this output file, but it is a blank file, get rid of it. We don't want to keep blank files on the system for no reason. Let's take a look at that. Currently, if we lsltr, you'll see that the log abstract.shell.errors exists, but it's a 0-byte file, so we shouldn't keep this file. Let's rerun log abstract.shell. Let's lsltr again. Notice it's now gone. Now what we need to do to test that this does work is to create a condition that will actually generate errors. So we'd actually have to have some sort of problems from grep. In order to create that condition with the way the script is now defined, we'd actually have to get rid of the checking for whether or not it's a 0-byte file. And then it would work. Great, so that's what we're testing for here. It's working. Now we can define as many log files as we want. There are other log files in this directory. Let's take an ls here. We have, for example, messages, mail log, we have MySQL, we have secure. Let's add those. So log 3, for example, let's paste a few more. Log 3 can be MySQL. Let's just double check. It should be MySQL d.log, and it is MySQL d.log. And for the most part, these files are all text files. Not all, but most are. For example, WTMP isn't a normal text file. It's a binary file. Log 4 will make the secure file. So now we're going to go through for it, but of course we need to update our for loop. Using brace expansion will send us up to 4, and now the script is much, much easier to work with. Now we can rerun log abstract, and it'll cycle through all the files. Now if we LSL, let's go to varlog here just to check out the other files. LSL MySQL d.log as well as secure. These files are both blank, so they come up with nothing, as well as mail log. So we have files that are empty. So let's add cron to the mix. We'll cut this and paste it twice. Log 5 will be cron. And we'll just add to our brace expansion here. Now we'll cycle through a file that should certainly have some input. Now we have stuff for cron as well as for the general system file messages. And they're all matching October 17th entries. And to prove it, we can add other files. For example, we have crons 1 through 4. Let's change this to cron 1, for example, which will contain entries up to 4:02 a.m. And there you have it. It runs and it brings all the items back up until 4:02 a.m. this morning. And if we lsltr here, there are no errors, so the file has been deleted. If there are errors, then we'll run into problems. Now, how do we culminate what we've done into something that we can capture, something logical? Well, we simply just use redirection, which of course we've shown you. Redirect this to the new file, and we'll call it perhaps a file with a date, or we can do it from the grep line, either or. But we can send this to a file which will use date as command substitution, so date perhaps plus f dot log abstract dot shell, for example, or let's just say log abstract, as any name, doesn't matter, and the output will be sent to that particular file. That's lsltr. Now we have this file, and it contains all the entries. So now we can less 2004 1017 log abstract, and it'll contain entries for varlog messages. These are all from varlog messages. So as an administrator, you get now a synopsis, an abstract of what has occurred today. When we're finished with one file, we'll see our delineator. And if you go back, you'll see varlog messages ends, cron begins. And we've totally ignored the other files because they're 0-byte files. And we could add additional logic in here. So for example, if the file were a 0-byte file, then we could say something like, well, we saw the file. We could echo, we saw the file, but it contained nothing, perhaps to a separate log file. But the fewer files you maintain, the better. And we have a little cleanup script here. We can just put a comment. Cleanup standard error generated file from grep. Excellent. So this is a simple script. As usual, we haven't gone into pretty long scripts. We really don't need to. Scripts typically don't need to be long. They need to be concise. They need to get to the point and do what you need to do. And we know how to loop through some log files based on a variable that we've set. We know how to set the standard error to have it go out. We know how to check whether or not, using -e and -s, whether or not the file actually exists and whether or not it's 0-byte. And we know how to clean up. In other words, if it's not a 0-byte file, or if it is a 0-byte file, remove the file. So we have accomplished our log abstraction. To expound on this idea or on this particular script, just keep adding more log files, and you'll have the output in one file. And you can also use grep to send the output using redirection, append redirection to a log file, or just call the script and send it to a particular file. Now you can also have this particular script run from cron. Just put it as a cron entry, either as a user who has rights to read the entries in varlog, or as root, or as a system cron tab entry, and it'll create the files on some sort of interval, perhaps before you get in, maybe early in the morning, etc. So it's quite easy to implement, but we just want to show you some of the logic that you should put in so that you don't waste too much time and end up with superfluous output.